Oh, hey, Steve, schedule yourself a nap for later. Absolutely. Welcome, everybody. I am Dr. Sherry McGuffin. I'm STEM coordinator from Advanced Kentucky. And apparently, you all are here today to talk about AP Computer Science principles and particularly the create task. So let me go ahead and share my screen and we will get some introductions. If you don't mind to introduce yourselves and go ahead and introduce yourselves in the chat and also tell us where you are from. I'll give you the quick blurb and overview of what's going to happen today. So again, it's AP Computer Science Principles and talking specifically today about algorithm and developing programs and the create performance task. Give me a thumbs up. Everybody can see the screen that I just shared, correct? All right, excellent. So Joanna Stevens is going to be our expert presenter today. Thank you, Joanna, for being here. Joanna is at Garrard County High School in Lancaster, Kentucky. So just a few reminders while we're on the review session. This particular session is intended for a Kentucky audience, but we welcome people from anywhere and everywhere that want to learn a little bit more about the create task and computer science principles and what's to come. AP is a trademark registered by College Board. It's not affiliated with and does not endorse this product. But just going back a little bit, we do encourage session participation. So if you do not mind to go ahead and, like I said, introduce yourselves in the chat. And I will be monitoring the chat while Joanna is presenting. And so we'll try to get all of those questions answered that you have. Advanced Kentucky has Twitter and Facebook at Advanced Kentucky, if you don't mind, and then we'd love to have you follow us. And here is my personal email, smcguffin@kstc.com and at Dr. McGuffin. For those of you that don't know me, I support STEM education in Kentucky through Advanced Kentucky, as well as particularly computer science. And I taught math and computer science for 22 years, so computer science is my thing. A little bit about meeting etiquette. Microphones are automatically muted upon entry. So if you do want to ask a question or pop in or anything like that, then just remember to unmute your microphones. Your videos are also automatically muted. And, please leave your video off unless otherwise asked. We do not mind if you have your videos on. Honestly, we love to see your faces. I know that sometimes that people have bandwidth issues. Also, please find the chat button at the bottom of your Zoom screen, and we're going to be monitoring the chat along the way. So ask away. This content session, review session, will be recorded, and it will be available at on our webpage at AP Exam Content Review Sessions at bit.ly/Advanced Kentucky. So all of those recordings are available, including the past review sessions, content review sessions. So if you'd like to view those, and we also have the schedule for any upcoming events. So with that being said, I am going to relinquish the screen and turn it over to Joanna Stevens, have her introduce herself, and let's let it roll.
Okay, thumbs up. Can we see my screen? Okay, and then I'm going to okay, never mind. I'll just leave it there. Okay, so this first little bit will be about algorithms and developing programs. All of the resources can be found at this bit.ly, and I will put that in the chat. So a little bit about me. So I'm Joanna Stevens. I have taught math. This is my 11th year. of teaching, and math is my background. So right now I teach Algebra 2 and AP Calculus. But about 4 years ago, I started teaching AP Computer Science principles. I took computer science in college, and I loved it. But I took a few years, stepped away for a few years, and pursued my math passion. But when College Board came out with this AP course, with the help of programs like Advanced Kentucky, I was persuaded and encouraged to teach this class, and I'm so glad I did. So I've been teaching this for 4 years. Last year I read with College Board over the summer. And then right now I teach at Garrard County High School. So looking in the chat, we have lots of people from Kentucky. So Garrard County, Lancaster, that is south of Lexington, about 30 miles just south on Nicholasville Road. But then I also see we have people from California, from New York, from Michigan. So thank you for joining us. It's a sunny day here in Lancaster, a little chilly, but I'll take the sun over the rain, the snow, and all the weather we've had recently. But please feel free to chime in. I'll try to keep track of the chat. I'm used to doing all my lessons all week on Google Meet, so switching back to Zoom, a little different, but we'll figure all that out. But feel free, if you have questions along the way, to send those in the chat. So this first segment will be about algorithms, and then we'll really spend a lot of time talking about how algorithms are scored in the create task, and then really focusing on other aspects of the create task as well in that second hour. So when we think of algorithms, so we have a set of instructions that accomplish a task, that solve a problem that we have. And we focus on 3 different types of those algorithms: sequencing, selection, and iteration. So we look at sequencing. I tell my students this is just like a recipe. We do step 1, step 2, step 3. We follow things in order. Selection, those would be our if-else statements that we look at, our when, our conditionals. And then iteration, those are our loops, our for loops, our while loops, things we continue doing until a condition is true. So what I want to start with is I'm going to send you all a Desmos link. So you can join with that code, or you can click on this link. Hang on, I'll pull that code right back. So you can join there. We just have a little check-in screen first. Since March Madness, it is happening, and normally that is prime time in Kentucky, but unfortunately this year we're not a part of it. So, but still, just how are you feeling today using that? Those March Madness emotions. It brings out lots of emotions from all of us. And then once you do that, feel free to share on that screen. And then the second screen, just kind of where are we with algorithms? What do we know?
And Joanna, I put the code in the chat so that we have reference to it if we need it.
Thank you. So on that first screen, it looks like we are all over the place. Several of us are relating to the Wisconsin player. Whoops, I guess Siri heard me there. Several of us are relating there. We're tired. And I feel that this week was my first week back with my students 5 days a week in person. We had been doing a hybrid schedule, like A day, B day. So this was my first week of having on 5 days, all the students that wanted to come in person. Now I still have a chunk that are virtual. So we're managing both of those at the same time. So I feel that tiredness. And I also feel like Etta says, we're dribbling and we're just trying to make it work. That's how we're making the most of the situation we're in. And I think that's very true for this year. And some of us are just ready for spring break. I know here we have 2 weeks until spring break. But some of us are feeling refreshed or overwhelmed. So we're kind of all over the place there. And I know a lot of you are teachers based on the names I'm recognizing. But I use these check-in screens frequently with my students. And especially during the create task, it's really good to get some feedback on how things are going. And I try to do a different check-in with them every day, just so we can, see where I can intervene. I'm limited when they're doing the create task on what I can do, but at least I can see, if something else is going on outside of class that I need to be aware of or patient with. And then on screen 2, we've got some card sorts, or we have a card sort where we're looking at the types of algorithms. So I just briefly, before we got started, talked about the 3 different types. So we have iteration, we have selection, and we have sequencing. Those are the 3 types. And then we have a description of what each algorithm does, as well as an example of what would that code be? Where would this fall if we were classifying it? So it looks like several of you have finished it, but I'll give you another minute just in case you haven't. Stefan's are all green, Augustine's all green, Charles is green, Etta, Camille. So that means you are correct. And then, so I'm using your anonymous names here. So I don't want to call anyone out, but I've given you all an anonymous math name, and you should see that at the top of your screen there.
There was a comment in the chat, Joanna. I've heard that if you have selection and iteration, you definitely have sequencing. Is that true?
I think it's true. And that's something that my students have talked about, that if you have the selection and iteration, therefore you have 2 things going on and they're in order. I tell my students that sequencing works as long as you have 2 things occurring. And I know that's part of the create task requirement, and that's where we've debated it. But I think if we focus on the selection and iteration, the sequencing is going to come natural.
And I know when I was in the classroom, I always told students, use the wording specifically from the rubric and apply it to what you're talking about, and that will leave your readers not guessing.
Yes. I tell my students frequently that they want to make their grader happy. Don't make them search. Don't make it a scavenger hunt for them to look for things. So I'm going to check in. Yes, follow the rubric. Look at the rubric. What does the rubric say? I feel like I say, what does the rubric say every time they ask me a question. They're going to make a meme of that, I feel like, at some point. So I'm going to check in with Camille Jordan. So if you are stuck on the card sort, Camille has theirs all sorted with sequencing. So that's everything's in order, top to bottom. And as I tell my students, 2 or more things going on, and you have sequencing. Selection, that's our if else, our wins. Code will run if a condition is met, and it evaluates true or false, so our Booleans that appear. And then iteration, for loops, while loops, repeat, and the computer will keep doing those things until the condition is met, or it'll be an infinite loop. But these card sorts have been handy throughout the year with computer science. So I use Desmos a lot as a math teacher, but I use it quite a bit in computer science too, especially with the hybrid virtual situation we've been in this year. So on screen 3, those are just kind of summarizing the card sort. So this is helpful, you know, if a student missed the card sort, they can see what we should have there. And then also with Desmos, since we do have several teachers on here, you can code it so it gives the students feedback on the card sort if they're doing it without you, to make sure that they're on the right track there. So those are our 3 big types. And students, I mean, it makes sense for most of the part, but I really like to nail it down to make sure that they understand the vocabulary, iteration, selection. So we're going to make sure we've got it by doing a Kahoot. And so you can do this on your phone or on your screen. My students like to do it on their phone, so that way they can still see the questions on the screen. So there is our code. Thank you, Sherry. Is anyone else trying to get on?
Joanna, usually the Kahoot music is playing. Did you want it playing?
I wonder if
When you share your screen, there's a little box at the bottom that that you have to click to share the sound. There we go.
There you go. You hear it?
A little bit.
A little. It's not as loud as normal.
No. There we go. I had not noticed that, Steve. You are exactly right. Kahoot codes have increased by a digit. That is an interesting computer science discussion topic.
It is. Yep, and I think GimKit also increased, and then Desmos also increased their character codes too. Big trend there. So Susie, is it letting you on? There you are. Okay, so we'll go ahead and start. So for this code, would it be iteration, selection, sequencing, or none of the above? Okay, so that while or the repeat would be a loop, and that would be our iteration. So I like to do the Kahoot to pull in different types of code. My students use JavaScript, so I like to use different examples so that way they're not just always used to seeing the code, the iteration examples the way they see them. So we look at others that are there. So Maddie looked to be the fastest on that one. So selection, this one did have an if else. If the answer was 6, they got +1. Otherwise, wrong answer. This one was iteration because it's a for loop. Several of you put sequencing, and I think this is one that meets both. And so I guess you should be able to, this would be a good one, I guess, on the AP exam where they can select 2 answers. And there is, I know somebody asked earlier, and there's confusion even among my students, even me myself. Like, I guess I always default to iteration or selection. And if those aren't present, I do sequencing. But I do think this one has sequencing since it's moving forward, then turning left there in the loop. So I understand why that answer was picked.
I almost always default if I see a loop of some kind, I'm going to choose iteration, especially if it's a for loop. That's usually the default.
Mhm. Good. So we have a while loop there. Now Steve has a big lead right here. Good. So there's our sequencing. We have our variables, we have our calculation, and then we have our print with what it's returning right there. Very good. Sequencing. Oh, the box. Oh, and Steve has even made a selection. He's written some code to help us decipher which one it would be. So this is we see that if, so it is our sequence. Perfect. That might be our first perfect one. Oh, that one's smaller. Good. So that is one. Iteration trumps the sequencing there, since we do have that for loop being present. So last 3 questions here. So this one, just focusing on what are those examples of. So anytime we have those if statements, that is our selection. Very good. So we're getting our first name, our last name, and we're printing it out. So those are our sequencing. And last question. And our loops, while loops, repeat loops, for loops, those are all our iteration. So here is our winner's podium. So congrats to Steve, Nadia, Maddie. So hopefully that helps. And teachers, feel free. That is linked on the bit.ly in the Google slide presentation, so you can use that Kahoot. You can also, that's where like my Desmos activity is too, so you can always copy those. We will come back to the Desmos, so don't close it out yet. And if you did, it's okay, I'll send it back to you. So big thing with algorithm are the 3 types. And then we look at how do we need to use algorithms in our create task. So the second hour we'll focus on create task as a whole. But right now I want to focus on just the algorithm component. So the create task, if we look at the score sheet, and again, we'll do that second hour, so I know this is kind of a weird order, but there's 6 rows on the rubric. 2 of the rows really do focus on the algorithm component that's in there. So on row 4, students in their create task, in their app, we have to have a student developed procedure. So we have to have the function or the procedure, whichever terminology we use, that has at least 1 parameter that has an effect on the functionality of the procedure. So that means they can't just have a parameter. It's got to be useful for the function. So they can't just stick it in there to check the box. It has to be useful. And then they have the written response. So for this section, we're just going to focus on the requirement. So the requirement of a function with a parameter that's helpful. We'll talk more about the written responses in that second part of the session today. So that's row 4. And then on row 5, this is where the type of algorithm has an impact. It has to include all 3. So all 3 things that we have talked about have to be present in that create task. So that wouldn't be a good Kahoot because it would have all of those. We want to check all the boxes. We want it to have the loop, the if else, and the sequencing. So as we've talked about, the sequencing comes pretty natural for students when they're writing code, but they have to be really intentional on they need a function that has the parameter, has a loop, and has an if else. So those are the 3 I keep telling them, make sure it checks all of our boxes for that. And so okay, so Janine has a question. If the user-defined function calls another user-defined function, should I explain both? And so I assume they're referencing this bullet that says, explain in detailed step how the identified algorithm works in enough abstraction, in enough detail that someone else could recreate it. I'm sorry, I was thinking ahead. I think that they would reference the function and say with that, the one they're calling, I think they would describe what it does, but I don't think it has to be in as much detail, because I think that's an example of that they're using abstraction there. I think they only have to describe in detail the big one that they're using, and then they can say, I'm calling a function that does this. Yes, that's what I would tell my student. And so here it is again, because I can't tell my students this enough to make sure, they have to have at least one function that has one or more parameters, that has sequencing, selection, and iteration. So we have looked at the rubric. I share this screen with them almost every day while they're working on it. I send them Google Forms where they can do a checklist. Does your app have these things? Just to make sure that we're hitting those big things, since it is 2 points out of 6. So we are going to look at some. If we go back to that Desmos, like, would it count? Would it get the point? Now we're not going to look at the written responses for this. We're just going to look at the code. So let's see. I've pulled several. And so once you get to screen 5 on the Desmos, in fact, I'll just send us all there. It has code on the left. And then I went ahead and put the rubric there on the right. And I know it's really small, but if you click the arrows, it can come back. So row 4, we're focusing on, does it have a parameter? Is the parameter useful in the function? Would you give it a point or not? And I know just pretend the written response is wonderful and it meets all the requirements. And then, so for each code, the next one we'll have row 5, and I put the row there so you can see how would you score it? What are we basing it on? Would you give it a point or not? So I'll give us some time to work through. Go ahead and do screens 5 through 12 there, looking at the different code. But if you get stuck on one and you want to chat about it, we can. And then we'll go over, would it get the point or not? So just to clarify, well, on the ones that say row 4, we're looking really at the parameter. And then the ones that say row 5, we're looking at the iteration, the sequencing, and the selection. Yes, yes, Janine, that works. Okay, so it would get the point on row 4. So Janine's asking like if the parameter only affects the number of times the loop executed. Um, and then it says there's text that says it has to execute a different section of code. So that would come in row 6 of the create task. So in row 3 or row 4, is there a parameter? Does it affect the functionality of the procedure? And then on row 6, where you have to show 2 different calls to the function, yes, row 6 is for the that D written response that they have. And so on row 6, that's where I think that parameter would run into an issue, because it does have to use 2 different types of the code. Yes. So like if you have an if else state, I'm encouraging my students, like if you have with your if else statement on that row 6, do something where it goes to the if and something where it goes to the 6. Good, I'm glad. Yes. And it is either they get the point or they do not get the point, and there's no middle ground. We'll take we'll say 2 minutes on those practice scoring, and we'll talk about it. I know you may not be completely finished, but just for the sake of time, we'll start talking about those. Yes, yes, Janine, you can. So on the Bitly, the Google slide, there should be a link to the Desmos. And you can do it just as it is from the teacher perspective, but you can also copy and edit it. Like if you wanted to delete slides, add slides, yes, but you can customize that.
Okay, I feel like I should maybe talk. Thank you. My students are in the middle of the create task, but it's not like they have to submit it right away. So I might actually wait until they're done to do it, but just they need to check and double check and triple check that they're getting all the points before they submit it. So, okay, thank you.
No problem. And what I've tried to do with my students as they've worked, mine are basically finished, or they should be finished. I know they're not yet, but like we did practice scoring on the whole thing with a couple before they started it. But then as they've been working, like we did a Desmos that just focused on the row 1. And then I was like, okay, now you all go do row 1. Then we did rows 2 and 3, rows 4 and 5, and then row 6. So I tried to break it up so they could really just focus on how do I get my points for these rows. But I think that's been helpful. It's been helpful for me to just feel, I hate that working on the create task because I feel so unhelpful as a teacher. Like I want to intervene. But it's been some good breakup. So that way, like we would do a presentation for maybe 20, 30 minutes of class, and then they would have the rest to work.
Okay. Do you mean you like went through an example? Is that what you mean? Or
like before they started, I gave them like, this was what a student submitted.
I mean, like when you went one row at a time, I'm sorry to interrupt, but like,
yes.
you mean,
no, you're good.
You showed an example? Because my kid's already in the middle of it and we already have a plan for that. So I'm going to have to wait till the end, but that doesn't mean they can't like change their written responses.
Right.
Okay. So it would be maybe a good idea to say, okay, I'm going to show an example of row 1 and what would be a perfect score and what would be like a not so perfect score. Now go look at your row 1. And
yes, I think
that's completely legal to do that. Okay. Yeah, it's very like counterintuitive not to help them. I hate it.
It's so weird as a teacher. But yes, like you could do this activity and then tell them at the end, now go look at your code for rows 4 and 5. Would you get the point or not? I think that'd be extremely helpful.
I actually did the exact same thing and with my students is I would break it up and then give them time to work, then give them examples, code examples, compare them with the row rubrics, and then do the same thing that you did, Joanna, say, now go look at yours and compare it. And again, it's giving feedback, but not giving them direct feedback on their own work or giving them tools, really, not necessarily even feedback. It's giving them tools to use.
And then at the end of the day, it's up to them to actually do it with theirs. So yep, exactly what Paul said. At the end of the day, they have to follow the rubric. They have to listen to what I'm saying. So, and I feel like that's even harder this year since we are virtual. At least when they're in my classroom, I can see them. They're at least looking at me. But we will go ahead and take a look at these. So starting at screen 5. So let's see, this one would get the point on row 4. So you can either follow along on the Zoom, or you can look at your own screen there. But row 4 would get a point because it has parameters. So it has 2 parameters, word and times, and it uses those in the function. So it uses times to say how many times for the loop, and it uses word when it's returning the word, the plus word right there. So it would get the point based on the code. Now they would still have to do the written response, but we're assuming they wrote a really good written response. On screen 6, this one, as you all said, several of you say, it has iteration with the loop, but it does not have selection. What Stefan says right there, there's no selection, there's no if else. So it has the loop, it has sequencing because there's a variable, a loop, a return, it's all in order, but because it doesn't have the if else, there's no point right there. So that would be easy for the scorer when they're looking at that. Like they don't even have to read the written response to see that they would not get a point there. So Janine, that goes back to what you were like, it's all or nothing. They could have the most beautiful written response that explains how the function works, but because there's no if else, they lose that point. On screen 7, they have a parameter, but the parameter is not used. The procedure with the parameter does not use the parameter. That's what EDA says. So it has a parameter of points, but when I look at the code, points does not appear. So I think this is that would be a student trying to stretch it. They try to sneak it in, but they've got to use it in some way that's helpful for the function. On screen 8, this one does not do a point because Camille says there's no iteration. There's no loop here. So they establish the score, they add 1 to it. There's an if statement where to determine if the game should end, but there's no loop. There's no while, for, there's nothing there that's occurring over and over the iteration. So they would lose the point. On screen 9, see 5 of you say it should get the point, and it does. So it has the parameter of a list. So it's actually pulling the whole list in as the parameter. It's using the list length for how many times the loop should run, and it's using the value in the list inside that loop there. So the parameter does have a big effect on that one. On screen 10, let's see, 4 of you say no, 2 say it does. And to answer that question, yes. They can help, they can debug each other's code. A lot of the material from College Board this year says, like it'll say your partner, but it can be, as long as they are a peer in that class, they can debug each other's code. They can help each other debug it. And you all are all in agreement on this one. It does not get the point because there's no selection. Good. So Dora says no selection. It has the loop, it has the sequencing, no selection there. 5 of you say screen 11 would get it. It's pulling a list similar to another example. It's actually pulling the length, it's pulling an item, and then it's using the selection to pull the other item. So it would get a point. And then on screen 12, this one has the trifecta. So it has the loop, it has a selection inside the loop, and it has the sequencing there. Yes, I agree with you, Paul. And it's, I'm having success with some students, but it's really dependent on their personality if they're willing to do it. So I'm doing Google Form check-ins where they just say where they are, and they have a checklist. This is what I've done. This is what I'm working on. And then I put a question like, do you need help with something? And then I just have a Google sheet that the whole class, or Google slide that the whole class can see for those things that are helpful, that they need help for. And then I might have a student say, like, Paul might volunteer to help Janine, and I'll put them in a breakout room and they'll share their screens. But again, that's, some of my students are all about that, and some I can't get them to volunteer for anything.
Can I ask a question? Wait, oh, did I stop playing? I think I might have forgotten it. Hold on, I'll come back if I remember.
You're fine. They are not in the bit.ly, but I'll add them. We're getting ready to take a break, so I'll add those Google Form check-ins. And that's been helpful for my students. Again, only some of them, just based on their personality. But I'll add those so you can see what I've sent them.
I remember what I was going to ask. If I have a student that says, this is the function that I'm going to choose to highlight, will it work? Like, is that legal? Or do I have to say, I can't help you with that? Because I had someone do that the other day.
Like they showed you the function?
Yeah.
No, you can't tell them if it meets, right?
Okay. Okay.
Yeah, that's when I would answer it with a question of, does it meet the requirement?
Well, do you think it would? Or why don't you look at your rubric or something like that? Okay.
Yeah.
I mean, I'm
Absolutely.
trying to not help them at all, but it's really, like I said, counterintuitive. Okay, thank you.
Yeah, it's sketchy what you can do and what you can't do.
It's nice to know they can help each other, though. I didn't know that. I thought they could only help their partner debug. So.
They can help each other with the debugging and the coding. I don't encourage my students like to give feedback on each other's like rubric. Like they can't score each other's. I would love that if they could. That would be awesome. But they can help each other with the code. Not so much does it meet requirements.
Yeah, I had a student say like, can I look at my partner's written response if we don't work together on it? And I said, no. I said, you should pretend like you don't even know what each other is writing. Like you have no idea. Don't even discuss it. And so that was the right answer.
Yes.
Okay.
The College Board, I think, is very clear on they can help with the code, but the written response and the video have to be completely independent.
I feel like it says somewhere they can't help with the code. Like, I feel like I read that, but I'm going to take your word for it.
And some of you can chime in. They can help with the debugging. They just can't do the other two where they get all their points, the written response and the video. Any other questions on that sample grading there? So we're getting close to the halfway point. I'm going to go ahead and I've unpaced you on the Desmos. Just some algorithm practice there at the end. There's code on the left, and then they can trace it on the right. So this is not create task related. This is just robot practice. But Desmos is great for this because they can actually sketch it on there. So they can like move forward and whoops, I went a little too far. They can move forward and turn right, and they can actually trace the code. So they don't have to, we don't really have time to do it today, but those are screens that you could use with your students to practice. And then you can see how they did and, identify like, oh, right here is a mistake. But I tried to put an example. The first one, that's just sequencing. I put this diagram on there for them to see just a different way of the code, to see the loop or an if else there, where they would cycle back through that. So just some different ways of seeing some different things, and they can actually trace the code on there. And also another thing with algorithms that's been helpful this year is Delta Math, and I'll put that in the code or in the chat, sorry. But Delta Math has some great, it's made for math, but they're adding a lot of computer science things, and they have some really good robot activities. They have some good loop activities and conditionals just for students to practice tracing those algorithms. So I use it a lot in my Algebra 2 and Calculus classes, but it's nice in computer science for just students to have the practice of tracing the code. And they get feedback on whether they did it right or not. So any questions about algorithms? Paul, I agree with you. I'm not scoring this year either. I think I'm just tired of sitting in front of a computer. And yes, please keep asking the questions. The rubric's new to all of us this year. Okay. So Sherry, how long of a break do we want to take?
Well, I've got 11:59 on my computer right now. Let's take 6 minutes and come back at 11:05.
Sounds good.
All right. We'll see you all at 11:05. And we are back. And I just realized I was on mute, so you probably didn't hear all that good music going along with the timer.
I did.
Oh, you did? You did hear it. Okay, good, good.
Yeah, great music.
Oh, well, we have to stay awake and keep everybody awake during our breaks too. So I usually break out 80s music if I can. Joanna, it is all yours.
Okie doke. I'm adding these status checks so that way, on just a second. Can you all see my screen again? Yes, okay. And let's see, I have lost the chat box somewhere. Okay, we're good. So this is a different bit.ly. I just made them since they were 2 different topics, 2 different Google Slides. But there's this one. And then the first screen that I just added, these are the status checks that I've used with my students that I mentioned in that first segment. But it just asks the students for, when they're just starting out, do they have an idea for what they're going to do? And I really focus on, I want them to have an idea for the app, but you need to have an idea really soon on how you're going to use your list, how you're going to use a function, your loop, your if else, your parameter. And then have they written their code? Would they like help? And then just like kind of a summary of where they were in the create task. So this is the first one I gave them maybe after a week of working on it. The second one, it's more, have you done these things? What have you completed? Have they visited the AP digital portfolio? That's something that's hard to do. Since some students are in person, obviously the ones in person, I can see that they're on the digital portfolio, that they can all access it, but the ones virtual, I'm relying on them to tell me that they've been there. What are they currently working on? Kind of give me a status check of where they are, and what do they need help with. But it's been helpful for me to just see even the students who never chat in the chat box, never unmute themselves, at least they'll fill out the Google form. So I get some type of update of what's going on there. So to start with the create task, instead of telling students everything there is to do, I have a scavenger hunt that they complete. So I'm going to let you all see that. And this is something like I do at the beginning, but you could definitely do at any point during it, just to make sure they know all the rules here. So there is the Desmos code there. It is a different Desmos. We won't be using the other one anymore. And let's see, I'm going to give you screens 1 through 7. So the first is just kind of a, where are you? And if you're a teacher, you can just kind of answer, where are your students with regards to the create task. So you can move that green dot to represent, you haven't started it. And that's fine. You still have plenty of time. So don't stress if you haven't started it. Desmos is free. Yes. It is similar to Pear Deck and a lot of the features. Desmos has math type, it has graphs. So as a math teacher, this is my go-to. But all of the features of Desmos are free. The only thing that costs money is the middle school math curriculum. And that's the only thing they charge for right now. But again, don't stress. If you have not started the create task with your students, you still have time before that deadline in May. So like if I was filling this out for my students, I would say we're like between a 7 and an 8. They've made a lot of progress. They should be getting close to finishing it. Some are. But I probably have some that have started it and made goals, but need to make more progress too, sadly. If you have any specific questions that you want to type about the create task on screen 2, feel free to do that there or in the chat. So then starting on screen 3, you start it's just a little, I call it a scavenger hunt, but it has links for the students to explore like the College Board's AP CSP exam page. First we need to establish how important this is for their score. And it should give you feedback. Like if you type in a wrong answer, it gives you X. When you get the right answer, it should give you a check mark there. So I'll let you all go ahead and answer all the way to screen 7, and then we'll check in there.
Just as an FYI, Joanna, a shout out to your influence of Desmos. And I'm teaching 3 college classes, but 2 of them I'm using Desmos and have been using Desmos with in-person and virtual students all semester. I have not printed one single paper the entire semester.
Wonderful.
Yeah, it's completely paperless.
Yes.
Than what students use to take their own notes and things like that, but completely paperless 100%, which is awesome.
Yes. Now that we have students back in the building, like I used the copier machine for the first time this week, and it was just like, oh, I don't miss this at all. I have not had that happen. I've had students waste time in class where they haven't done anything. But I mean, they do have time, just depending on when they where we are. Like they still have time right now. They could start over from scratch. They just would have to do it on their own time, probably not during class if you've already had 12 hours.
And one thing to remember too is they don't have to complete the entire program as long as they have the components working for the parts that they want to talk about. So that's just something to think about. If they've spent 12 hours, say, what do you have working?
Right.
And does it meet the criteria from the rubric?
Okay, so do I walk through the submission with them? Yes, I do. Now this is something we talk about in class, that as a teacher, I do not really have the student, I don't like when I can't have the student view of something. Like on Desmos, I can click student and I can see what it looks like. But on the digital portfolio, I cannot see what it looks like from their screen. So that's really frustrating. So one day this week, I actually had a student share their screen. And we walked through, like, this is where you will submit this and this. And we tried to go through like video one day, so it's not so overwhelming, to see what it looks like on their screen. And I'm going to talk about the digital portfolio, but that I've encouraged mine to, as they finish it, go ahead and upload it, but do not hit submit final yet. Because I tell them I like to open it up, make sure everything is good, just to give them I can't give them feedback on if it's good meeting the rubric, but just to make sure the file's not corrupted or anything, that they've uploaded the right thing in the right spot. And plus I tell them not to hit final because they may decide to go back. There might be a video, but I'm not aware if there is. I know like there's a PDF for students about it, but if I remember correctly, there was a lot to it. So I kind of had to break it down for my students. I knew they wouldn't read it.
There was there was a webinar on Tuesday night given by College Board for students, and they walk through it. And that was the first time I've ever seen it through the student perspective of what the screen looks like. But they walk through it step by step, and that is published on the College Board website. If I find, you know how hard it is to navigate that website.
Yes, I do.
If I find it, I'll share it with y'all. But it was really nice to see, oh, they're going to see this and they're going to, you know, because we don't really know what, I don't really know what they're going to see. I've never, you know, it's new this year. So
Right.
yeah, it's out there for them. And it was geared towards them, and they talked to them at their level. And I'll go find that for y'all.
That would be awesome, Maria. That is in the first time in, what is it, 6 years now since APCSP has been an actual, well, since students have been submitting. I've never seen one, like, and from the student perspective at all. So that would be great.
I do think that was the first webinar they've had that was really geared towards student specific. I haven't watched it, but I was glad that they did it. But it was a good discussion in class with, you know, computer science students that, hey, when you all go on, if you ever make a program, make sure that you make it so I can see it from the teacher perspective and student perspective, or the user perspective, depending on what they make. Students can cut and paste the written responses from a Google Doc to the digital portfolio. And that's what I encourage my students to do. However, I've noticed a lot of them are just typing it onto the digital portfolio. It saves it every 2 minutes. And they just like doing it on there because the word count automatically comes up, and they kind of like that. I've asked them to do the Google Doc, but I think they're tired of having so many tabs open. So Gottfried, good question here. Graded and annotated examples. I'm going to share some. I've compiled all of them from College Board and for code.org. So that way they're all right there where they can see the video, the written responses, and the scoring commentary. So I've got a link in the bit.ly for that. Oh, and Maria just shared the webinar link. Yes.
There were a couple of other questions in the chat as well. There from Janine, is the input and output from video 4A different from the input and output for function 4D?
Yes. So the input and output in the video, it just has to show the user inputting something. So that can be them typing, clicking, going over something, selecting something, and then the output, and then the app doing something as a result of that. For 4D, that's going to rely on calling the function. But that does not have to be the same thing in the video.
And then thanks, Angela, 5 steps to a 5. And she recommended, or just made the recommendation there, talked about how it breaks down the create task for them to understand.
Good. I don't know anything about the written responses getting lost, but I do know there is a Facebook group where teachers can ask questions there. So I think that covered this questions there, but feel free to chime in as we go through this and talk about some different things. So just to quickly review those questions here. The create task is 30% of their AP score. So it's a significant portion of their score. The deadline to submit the create task is May 20th. At 11:59. So we talk about that with my students. I tell them, I don't want any of them waiting till that date. From those of you who have taught before, you know that the digital portfolio usually has uploading issues that day. So we don't want to be dependent on them giving an extension like they've done almost every year. But so we're going to have everything uploaded and submitted before May 20th. My students will. Hopefully. I always say that, and there's always one student who I'm checking at 11 p.m. and messaging like crazy. We will work on the create task for a minimum of 12 hours in class. I keep track of this with like, I have an agenda on a Google slide that every day I have like my learning target and what we're doing. And I just keep track on there, like 500 of 720 minutes. So that way students can kind of gauge where we are in the process. Every year my students have had more than 12 hours in class, but they don't need the full 12 hours in my opinion if they work productively, but we have procrastinators, so they do. And then on what do we actually submit to the College Board? And so this I think is important as students start off, making sure they understand, that there's 3 big things that they're going to submit: the PDF, the written responses, and the video, and really highlighting those are the 3 things, because it's overwhelming if you read the student handout from College Board. There's a lot on there. So I think asking, like doing this scavenger hunt, it introduces them to the information, but gives them something to read, like to hunt for, so they're not just getting overwhelmed of those things. So I'm going to give you a few more questions there. So go ahead and go through slide 12 now. Yes, you'll have access to this. I'll make sure that I have it linked in my bit.ly too. Yeah, so it is linked on that Google slide deck in the notes section. I put the teacher version so you can see it. So on screen 9, I saw several of you put code, which is correct. And the exact wording from College Board is you're allowed to collaborate with your peer on the development of the program only. So that's the exact wording that they use, is that program, but code is the same thing. So in this scavenger hunt, the students did learn about Control F, where they could search for the wording to find where these specific things were talked about in the PDF. Screen 10. It must be completed individually, independently. Let me think, I can't remember which one. Individually is the one that College Board uses. And so I really hit this big, like your video, your written response, it has to be individually. You cannot get help or collaborate on that. We submit 1 PDF file. And I know somebody put it in lowercase and it gave you an X. I'm sorry, that's me. That's my coding, that I have it, that it all has to be all caps. So I should make it less sensitive there. Maria, do you know the answer to Crystal's question? So maybe we'll see. My guess is, Crystal, they probably have to fill out the form.
Yeah, I had to probably shouldn't admit this, but I had to make an account as a student. It's like Vegas right now. Because I really wanted to see what the kids are going to see, you know.
Right.
And it's my first time teaching this course. Like, I'm defending myself in front of a jury. I'm like, so I don't know if it should be they said they were going to make it public. They said they were going to put it on YouTube. I'm waiting for it to be on YouTube so I can puzzle it for my kids. Yeah, if I find it someplace else, I will definitely send it out.
And so when we look at what our program has to include, it has to have all of the code, the PDF, that we need comments explaining the code, and big thing, comments that include citations. And so this is something I really had to work with my students on. And I know that next year I need to do a better job of this throughout the year, of if they get an image from somewhere, if they get sound from somewhere, they're really good at doing citations from code that they get from other, like if they pull code from an old activity, they're really good about that. But as far as images and sound, I don't think I hit that throughout the year as much as I should have. So we do need code comments for citations, the list, the procedure. So all those things we talked about in the last, when we talked about algorithms, but also the list, because we didn't talk about that. But we need instructions, we need the list, the function or the procedure with the parameter, calls to the procedure. So more than one call, we can't just use the function one time. An algorithm with a sequencing selection and iteration there. And I should add comments here because that's a big thing that we need to make sure we include.
There was a comment or question from Janine in the chat box about using Replit and their IDs for the video. And now there may be an update on this, but in the past, and this was a written response, I had a couple of students that accidentally submitted their names on written responses. And what I was told when I asked about it is the readers ignore any names. So it's not like they're going to be docked or they're going to be tossed out because their names are showing. Now, if there is something in which they can blur out their names, that will be helpful. But that was from last feedback that I got, was that if there are any names showing, the reader just ignores it.
We talked about this week with my students when they're making their videos. I encouraged them to use, some students have their desktop and they're making their videos with their video software, but on the Chromebook, like Screencastify and Screencast-O-Matic work well. And Screencast-O-Matic allows them to crop with a video. So I try to encourage that. That way there's minimal so maybe they could crop out where their name is when they make the video. I'm not sure if that would be possible. But I do tell them when they make their video to make sure they have like other tabs closed in case those are visible that have their name or something on it.
And Joanna, there's a question from you, Chen, about.
So this is different. This is different with the new create task and the digital portfolio. And this is something I wanted to see the student perspective of. So in the past, like for their code, they had to do the circles, the ovals, the rectangles, all that stuff, which is not necessary anymore. But you have to upload a screenshot of the code. So it can't be like you could use a Google Doc. You could put the code in the Google Doc and then screenshot it. But it has to be an actual image that they upload. Before, they really could just copy and paste the code and upload it with the written response. So Zoom recording of their screen, I would think that would be okay with Zoom as long as their name isn't in it. And again, like I know from scoring, if I saw their name, I did just ignore it. There is a free version of Screencast-O-Matic. It'll say it won't take the logo off, but that's fine. But Screencast-O-Matic is free. Right. And then when you're ready, go ahead and do the questions. I'm just going to go ahead and let you finish all the way to screen 19 there. Okay, so on screen 14, the video should be no more than 1 minute in length. In 3A, the written response describes the overall purpose of the program, how it functions, the input and the output. In 3B, it focuses on describing the list. 3C describes the algorithm. And then 3D, the call, the condition tested, and I saw lots of results, and I saw a return result, similar meaning there. And then screen 19, you will receive a score of 0 on the performance task if there's any plagiarism. So this is an activity I do to introduce kind of the create task with my students. Without me giving them all the information, they actually have to sort through and find it. It gives them an overview of everything. And then I introduce on screen 20. You don't have to do this, but I give them the rubric, and without saying anything, like, what do you notice? And so they usually, they notice there's 6 rows, 6 points. They notice it's an all or nothing type point system, that you either get the point or you don't, no partial credit. And they notice, and this is what I really try to highlight, that most of your points come from the written responses. So you're going to want to they're going to want to spend most of their time on the code, but those written responses are where the meat of the score is. So we try to really highlight that, and also how some rows, like rows 2 and 3, both go to 3B. Rows 4 and 5 both go to 3C. Yes, pretty much all their points. Yes, that really the PDF of their code is not, it's not critical, but they, we do, as scores, we use the PDF to see, to make sure they call the function multiple times. But sometimes the PDF isn't even opened by the score unless it's needed. Right, so the PDF is really not, it's nowhere on that rubric. It's there more as a reference for the score. So after I share the scavenger hunt with the students to get them introduced, what do we actually have to do? We have to write a program, and you can have a peer for that. You have to make a video. We have to answer 4 written responses, and then we make a PDF of our code. So I'm a checklist person, so I kind of make my students checklist people that this is these are the big things we have to do. If they don't submit a PDF, is their score 0? I don't know the answer to that. Does anyone else?
I don't think I've ever seen that.
I don't either, so I don't know that.
Because if they include sections of code, they've been able to include sections of code in the written responses in the past.
Right. So really nailing down these 4 things. This is what we have to do. So the first thing we need to do is we need to decide we need to pick a project. And so I really focus on my students to do something they're passionate about, to do something that interests them. Make sure that they have an input and an output. Make sure they have a list, so that when they're picking a topic, keep these things in mind. You need a list. You need a parameter, an if statement, and a loop. That those should really be what's in your head the whole time you're picking your topic. So I encourage them to pick something interesting to them. Make sure it has a clear purpose, because they have to describe the purpose in that 3A. And kind of give them, like, as far as their activity, their program idea, could they code it? Like, is it something you can do? Or are you going to have to go learn how to do something? Because that's not the purpose of this project, is to learn new code. It's to show off what you already know. And I tell them not to code to impress, that, pick something they know, and that no language is preferred over another. Like, this is not the time, my students have used JavaScript. This is not the time to go learn Python. We'll do that after the test if you want to do that. But for now, do what you know. No, it cannot be too simple. As long as they meet the requirements, I think simple is good. Focusing on, does it have these things? And I tell them to add the sparkle later. Finish your written responses, finish your video, then you can go back and add what makes it sparkle for you. But focus on keeping it basic, narrowing it down. So, just really going over this like the first few days. Oh yes, Paul's correct. It cannot be something they've already done. So I did say, like, do something you know what to do, but not something you have done. So it cannot be anything that I have graded or anything I've given feedback on. So even if it's something we did together in class and, we walked through it together, if I gave any feedback, they can't use it. They can use portions of old assignments. They just need to put in the comment that it's from there. But that their old assignments that they use, that should not be their list or their function that's getting graded. But other parts of the app can be I would be really careful with what they do with that. Right. I think that's a good way to look at it, Steve. I have a student this year who wanted to use, like, earlier in the year, before we really learned code, when we were looking at the design elements, he wanted to use his design elements and actually code them. So, like, whenever he did the project, it was just there for looks. It didn't do anything. So, and I told him, as long as, he can reference my design elements came from this project, which was graded, but all of his code is new, because he didn't know how to do any of that then. But that's really the only time I've really ever, I try to just kind of stick with what Steve said, that they can go back and look at it, but do, modify it to make it new. Your students can all do different things. Like, I have 2 students doing Python for their project because they know it and they're comfortable with it. So, I would just stress that they use whatever they're comfortable with. scratch, make code, all of those are fine. I think the biggest challenge with the create task is time management. So I'm constantly on my students about, showing them this is how much time we've spent, this is how much we have left. I've really stressed this year that if they're spending a lot of time coding, that if it's not about their function or their list, they don't need to spend too much time on it. So, I tell them, make their Sparkle list and they can add that stuff later. But to really focus on the list and the function and getting enough to make their video and adding the rest later. And I tell them they can always redo the video because they're always like, well, I want the video to be the best. But it's like, just make a video, have something. And so that way, if something happens, you have it that meets the requirements and you can make it look fancier later, but really focusing on the requirements. I kind of break it down from, this is just what my personal opinion of how I break it down with my students. That the first half, we are spending it creating an app and kind of spend an hour brainstorming, an hour focusing on how are you going to do your function and your list. How do you write the code? Debugging, adding comments, and generating that PDF. And kind of break it down. So that's kind of how I guided my students through that first little bit.
I had some questions about the slides being shareable.
Yes, you can. So that bit.ly that I shared with it, you can make a copy of it. I mean, you can share it as is, that's fine with me. But if you want to make a copy of it, you can do that as well. I'm completely fine to share it all. As far as, this is Paul's question, I'm always like, those are good because those are things I struggle with. So helping with the screenshots of their code. Whenever they ask for help, I show them like on my screen how I would screenshot code. As long as I'm not showing them what they should screenshot, I never touch their device. That's like also a rule, like, which obviously now with COVID that took it out. But I will just pull up a random code and I'll, show them the buttons to screenshot. With the video, I kind of try to do the same thing. Is I'll show it how to do it, and I'll try to use my Chromebook to show them how to do it on a Chromebook because it's different on my desktop. Yeah, you could change the Bitmoji. Yes, Paul, and I've struggled with that more so this year than ever because a lot of my virtual students are using their personal computer. I've had students intervene when that's come up, and I know they're not supposed to collaborate on how to record like on the video, but I feel like as long as they're giving tips and they're not saying like anything about the content of the video, it's more about the process. I haven't been telling them no. Tips only, yes.
One thing for future reference, and now knowing these kinds of things going into the next school year, is build in tasks throughout while they're writing code so that they're practicing little bits and pieces. So like they may submit to you a video of their code of something else completely different that they've written before they even start the create task. And then you're allowed to give them feedback or have them submit this written response based upon this section of a code. And do that prior to them actually even starting the create task so that they have models to go by.
I think that's a great idea. I had them make a video earlier because I knew it was coming, but I wasn't familiar with the create task before I really started it because I've just been in survival mode all year of knowing that it was actually an image of the code they uploaded because I had just had them copy and paste throughout the year. But I will say a positive from this whole pandemic experience. Yes, I think if you're not in that mode, I want to know your secret. But I think a positive is like my students are better at screen recording this year than ever before. Like, I mean, I had a couple that really, needed ideas and struggles, but like when I told them what apps to use, they were telling me what apps were better than those and what was wrong. So I do think there's some things that they're better at. They're better at uploading images because they've done it in other classes too. They've been on their device so much. But anyways, this suggested time, I pull this up very often with my students, like hour 7, we want to be making our video. Now, everything takes them longer than I think it should, but at least they have a frame of how those 12 hours should be. Yes, I agree with you, Steve. And citing sources, just reiterating that anything they pull from anything else, whether it's code, image, sound, library, that they need to give credit to that. And so this is just an example, like to put some code at the beginning, the end, where they upload the image, wherever they want to put it, and put some comments to say, the bird came from blah, blah, blah. The flower came from blah, blah, blah. And I know that's something I'm going to be more strict about earlier on in the year before the create task, that we just want to make sure we give credit to everyone. Yes, Janine, they can just put a link, and my students their minds are blown that they don't have to use some type of special format. Just tell me where you got it. It doesn't matter what it looks like. And again, I think we've hit this pretty big today. And we want the instructions, a list, a procedure, all those things. So I keep pulling that up for my students to see. Before they submit, I make sure, we want to remove our name. We want to make sure we've given acknowledgement. And then this is something with social media. I tell them, you're going to get excited about your app, and I want you to be excited. I want you to share it with your parents, your teachers, your friends, whatever, but don't post it anywhere. Just because you don't want someone else to take your video, take your code, and because they could turn it in, and then you're both going to get zeros for plagiarism. So I tell them to wait till July when they have their score if they want to post something. So don't post, they cannot post their video or their code anywhere. Because they can get in trouble for that. Whenever they get ready to make their video, I focus on, it has to show the input, it has to show one aspect of the function, and it has to show an output. It does not need to be long. It cannot have any distinguishing information about yourself. So I know, like, I had a student doing it on Google Meet, and he was using a Google Meet to record it, and his head was in it. So I pulled up this screen to, remind them, like, you can't have your webcam showing you while you record your video. And then voice narration, and this is new. I think, I don't remember this being on there, but it does say they should not have any voice narration. That they do encourage text captions if you need to say something. I don't know the answer to Maria's question. Can they share after May 20th before they get their scores? I would think that would be okay. After this, I mean, they can't change anything after that. So I would think that would be fine. We do focus on the video format, that they need to be one of those 4 types to upload. It can't be longer than a minute. Most of them are shorter than 30 seconds to accomplish what they need to. And then that file size they want to watch before they upload it. With the Chromebooks, these are the 2 best that I have found. And my students with desktops prefer something else. But these are both free, and these are both add-ons or extensions or apps that my district has loaded to their Chromebooks, because our school has a lot of things locked. These are 2 that are unlocked and free for them to use. I do encourage my students to not record sound unless they have sounds on their app or their program that they've made. Otherwise, you just hear a lot of background noise, and as a grader, that gets annoying. But if it's important for that program, definitely record it. As far as I'm gonna just share this with you. We're not going to have, I don't think we have time to go through it. But back to the Desmos, the next few screens focus on row 1. So last hour we focused on like rows 4 and 5. This is a similar setup where they can see the rubric, and then they have a link to a video, and then they have the written response. Would they give them a point or not? And so there's 3 examples of that. And then I also have something similar for row 6. And instead of giving them samples to grade, I have them actually like, here's a function and here's 2 different calls to it that are going to test 2 different conditions. So I model that for them with sample code. And there's the answer. And then on this one, example 2, I give them the code and I have them pick 2 different codes so they can see what that should look like on row 6. This is new. This has not been, and this is something now that I know what the create task looks like, it's something I need to do more of earlier in the year. But I really like it. I'm excited about this addition to the create task, the row 6 of the testing. So digital portfolio, we've talked about this. I really stress, do not hit submit final until they're 100% finished. And we do have to submit them all as final before May 20th at 11:59. Word count is 750 words. They allow 850. So I'm not sure why they have the rule if it's 750. But it does, I do like on digital portfolio, it shows them their word count. They can click save, but the digital portfolio does save every 2 minutes, auto save. This is the screen I shared with my students about taking a screenshot on their Chromebook for their code, that they hit the Control-Shift-Window button. It allows them to only copy the code that they need. It's not the whole code, that they don't have to crop it. And then kind of walk them through where it's saved. And then stressing that their image is readable, not blurry. And you don't want it so tiny, you have to zoom in. Just stressing a happy grader. We want to make the grader as happy as possible. I use Code Print to help my students make PDFs of their code. And I have them put it in text mode. They copy and paste, walk it through. This will print off their code for them in a PDF. There's other options. They can always put it in a Google Doc and export it as a PDF. Just putting in all those submission reminders for my students as much as possible. And then someone asked for this earlier, but this is a link to I've just compiled this for my students, and these are from College Board and code.org. I know there's several more out there, but this shows sample videos, sample written responses, and then the scoring commentary. So there's 9, and these are all with the current rubric, yes. So these are 9 from College Board, and the College Board has it on their website, but I realized my students were much more likely to use this Google Doc than they were to go to that website. We walked through A together, and I have a Desmos where we actually practice scored it together. But then they kind of like A starts off, A got all 6 points. I think I and H only get 2 points. So they kind of go from from examples to non-examples. But I think the ones that don't get full credit are really good examples to show students and to talk about, how could we improve this to get a 6? Like, what do we need to do? And having those discussions, I think, are really helpful. And then translating it to giving them time to like, okay, now go do the same thing with yours. And then my students use code.org, so I think it's helpful for them to see something in the format that they've used. And so those have the video, the written responses, and the samples as well. So I think we're getting close to noon. So as I said, I'm more than happy to share anything. So if something's not linked or something I've mentioned you want, I'm more than happy to share it. Just let me know and I can add it. But I think right now, I guess we have 4 minutes. Do you all have any questions?
And if you have any questions, you can open up your mic or open up your video and just share out. Or if you don't feel comfortable doing that, absolutely just type in the chat.
Thank you so much for this wonderful, it's really helpful. This is my first time teaching, so I was really anxious, but reading this, I feel much more confident.
Well, good.
Thank you so much. And I do have a quick question. I was going to the bit.ly CSP algorithms, and in my slide, it seems I have 11 of them, and I was wondering whether I can, how I can find the link to the slide you're showing right now. Maybe I just missed it somewhere.
So to these slides?
Yes, because the one I type in my browser bit.ly / CSP algorithms, and then
okay. Yeah, so I did 2 different presentations. The algorithms will be the first one we did this morning, and then that one I just sent, that will be the yeah.
Oh, this CSP create. Okay, sorry.
No, don't be sorry. Don't be sorry.
Thank you. Super helpful. Thank you so much.
Yes. Janine's question. Feel free to email me. This is my email address. You can also, I use Twitter a lot, so you can tweet me too. So you can feel free to email, feel free to tweet. Thank you all for coming.
And actually, I've got a summary screen on the and I'm going to share that. And with the summary screen, it has your email address, Joanna. It has mine. It has our Advanced Kentucky information as well. So I'll go ahead and share that so you can hopefully see it. Here we go. And nope, sorry, that's for my statistics class. I don't think you all want to see that one. But I'll put that up and we will get the right one up here. Now here's what we have. Okay, so we have the Advanced Kentucky website, advancedkentucky.com, and then our Twitter and Facebook, Advanced Kentucky, smcguffin@kstc.com. And I'm at Dr. McGuffin, and I tweeted out a pretty picture of you, Joanna, on so you'll see that after we finish today. Aaron Timmons is the content director for mathematics at Advanced Kentucky, and there's his information as well. Joanna Stevens, there you are. Garrard.kyschools.us. It is definitely not spelled as it sounds. So it's spelled Garrard, but it is Garrard County. So, and then handouts, any handouts and recordings. And Joanna, if you have any of the handouts that we want to add, we can add.
Sherry, it's still sharing the wrong page. It's showing us your stats.
Well, you all definitely don't need to see, well, unless you just wanted to. But. Here we go. How about that one? Now can you see them? Thumbs up? All right. So here is all the information. And handouts, any extra handouts you could send to us, Joanna, and we'll post them at the bit.ly, math.crs or Advanced Kentucky. April 24th, we've got robot algorithms and control structures and programming languages with Stephanie Younger. So come back and join us and let's talk about more about algorithms and control structures. Thank you, everybody. And if you have anything else, like I said, just hang out for a few minutes. I'll just finish the recording from here, but you're welcome to hang out with us for a few minutes just if you have questions and contact anyone as well. Thanks so much.